Welcome. We are discussing about polynomials, relation between zeros and coefficient of a polynomial. We have already seen the zeros of the linear polynomial ax plus b equal to minus b by a. We will not try to answer the question raised in section 2.1 regarding the relationship between zeros and coefficient of the quadratic polynomial. For this, let us take quadratic polynomials. First, say p of x equal to 2x square minus 8x plus 6. In class 9, we have learned how to factorize the quadratic polynomial splitting middle term. So here we need to split middle term minus 8x as the sum of the two terms whose produced first and second. Product, that is 6 into 2x square equal to 12x square. So we write that equal to this and this. So we find 2 into x minus 1 x minus. So we know that zeros of a polynomial is in which value of variables here is x, polynomials becomes 0. Zeros of a polynomial zeros of a polynomials in which value of the variables here x, polynomials become 0. Here this is the polynomial. Polynomials becomes 0 when value of x equal to 1 or value of x equal to 2. Therefore 1 and 2 are two zeros of these polynomials. Or in other words, we say that we find the value of x, that is variable, from the polynomial equal to 0. That is mean p of x equal to 0, then we find the x, then this x, value of x are also called zeros of a polynomial. And relation between polynomials, so we have and so on. So the value of the p of x is 0 when x minus 1 equal to 0 or x minus 3 equal to 0, when x equal to 1 or x equal to 3. The zeros of the polynomial are 1 and 3. Observe that we are discussing about this before just. Sum of the zeros, 0 is 1 and 2. 1 and 3. 1 and 3 are 2 zeros. Sum of the zeros 1 plus 3 equal to 4. With 4 discussing about that with this, and we say that 4 equal to minus of minus 8 by 2 because of minus of coefficient of x minus of coefficient of x square, minus of coefficient of x and minus of coefficient of x and minus of x square, by coefficient of x square, and product of two zeros equal to 3 into 6 by 2 means constant term by coefficient of x square. That is means the sum of the zeros of a polynomial we find in the from the polynomials that minus of coefficient of x by coefficient of x square, and product of these zeros in the quadratic polynomials we find the constant term by coefficient of x square, Similarly, another quadratic polynomials by the splitting method of middle term we find this and that finally 3x minus 1 x plus 2. In this form, find the zeros, we getting this x equal to 1 by 3 and x equal to minus 3 because of hence with the value of is value polynomial 0 when either it is 0 or it is 0. Hence, that is x equal to 3, x equal to minus 2. The zeros of the polynomial is 1 by 3 and minus 1 by 2. Observe that sum of the zeros, that plus that, equal to minus 5 by 3. Minus 5 by 3 means minus of coefficient of x and by coefficient of x square. That is product of zeros. Constant term by coefficient of x. Constant term is here, constant term is minus 2 and coefficient of x, so x square is 3. Constant term by coefficient of x square. So in general we, if alpha and beta are the zeros of the quadratic polynomials p of x equal to ax plus c equal to 0, a must be not equal to 0, then we know that in p of alpha equal to a alpha square plus b alpha plus c equal to 0 and beta zeros of the quadratic polynomial, so p of beta equal to a beta square plus b beta plus c equal to 0. Then we also say that x minus alpha is a factor of p of x and x minus beta also are a factor of p of x. Therefore, we write this x square plus bx plus c as k into x minus alpha into x minus alpha. Because of x minus alpha is a factor, x minus beta is a factor, where k is the constant term because of constant of x square. Is the k is a similar term of that. So we find this, multiplying this, we getting this kx square minus ki alpha plus beta and k alpha beta. So comparing the coefficient of the polynomials and constant term both side, we get both side from this and this. We get a equal to k, b equal to minus k of alpha plus beta, and c equal to k alpha beta. So this gives alpha plus beta equals to b by a. K means a, from here alpha plus beta equal to b by minus k, or k equals to a b by a minus b by a, and alpha beta equals to c by k, means c by a, because k equal to a. So finally we see that this equation on this alpha plus beta equal to minus b by a and alpha beta equal to c by s of this equation, ax is standard equation of quadratic polynomials, ax square plus, that is ax square plus bx plus c, the standard equation of the quadratic polynomials. The alpha and beta are two zeros, then alpha plus beta equal to minus b by a, alpha beta equal to c by a. This is the standard relation of the zeros of a quadratic polynomials. Next, sum of the zeros alpha beta, sum of the zero alpha plus beta b by a, coefficient of x square, coefficient of x by coefficient of x square, and the product of the zeros alpha into beta, so c by a, constant term by coefficient of x square. This is a two relation of quadratic polynomial coefficient between the zeros of the polynomial. Similarly, verifying the quadratic polynomials, this relationship between coefficient and zeros, then we first factorize this, and the value of the polynomials is 0 when find the value of x is x equal to -2 and -5. Therefore, putting this sum of the zeros being -7. Similarly, we get -7 by 1, the coefficient of x by coefficient of x square. Similarly, these are in the, and also we find the relation between coefficient and zeros of cubic equation. If a cubic equation has three zeros, alpha, beta and gamma, then alpha plus gamma is minus b by a, alpha beta into beta gamma plus beta gamma plus gamma alpha from c by a, and alpha beta gamma equal to d by a. The equation of standard quadratic equation is ax cube plus bx square plus cx plus d, where a not equal to 0. A cube plus bx square plus cx plus d is a cubic polynomial where a not equal to 0 and alpha beta gamma are zeros of the cubic polynomial. Then alpha plus beta plus gamma equal to b by a means b coefficient of x square minus of coefficient of x square by coefficient of x cube, then alpha beta plus beta gamma plus gamma alpha means coefficient of x by coefficient of x cube, and product of the all of three zeros alpha beta gamma equal to minus of constant term by minus of x square, coefficient of x square also. That is verifying these polynomials. These are very relationships between, these are giving that 3 minus 1 by 3 are zeros of the cubic polynomial this, and the verifying relationship. Comparing this, we get a equal to, comparing these polynomials, we get a equal to 3, b equal to -5, c equal to -11, d equal to -3. P of 3 equal to 0, P of -11 is 0, P of -1 by 3 equal to, calculating the 0. There's mean there 3 are zeros of a polynomial. Then we find the relation between alpha plus beta plus gamma means all sum of the three zeros are 3 minus 1 by 3 to -1 by 3 5 by 3 means minus of -5 by 3, that is minus b by a, and so on, c by a and minus d by a. This is means first relation. This is mean first relation is minus, second in plus, is sum first coefficient of x by x square, each is minus is come, second is positive, odd one negative, even number is positive, first plus negative, second multiply even positive. Similarly, next, first, this is first, odd is negative, This is second, even positive. This is third, is negative. Next, division algorithm of polynomial. Division algorithm of the polynomials. We get that let us consider with cubic polynomials, and if we tell us with the 1 zeros, that this is 1. This is 1 means then 1 x minus 1 is a factor of this, so we can divide is these polynomials by these polynomials, and we have learned about in the class 9, and we get the quotient x square minus 2x plus 3. Next we could factorize x square minus 2x by splitting middle term method. We get this, then we give this x minus 1 into it, and so on. And divide. Now we are divide this by x plus 2. These are not x plus 2 is a not a factor. X plus 2 is not a factor of this. Then they are we giving the remainder. Remainder must be the degree less than of degree of divisor. The degree of remainder must be less than degree of divisor. That is divider, and we divide that. Before dividing, we are processing these polynomials in standard form. Standard form means we rearrange this term as descending of exponential form. Descending order of exponential form means we first taking the highest exponential term of x, then decrease, and so on. Similarly, divisor also. In this case, divide and divisor quotient remainder. Divide and equal to divisor into quotient plus remainder by the division algorithm, and we apply this by the division method. This is approvable all time, true in all times. Dividing this by dividing this is, in this case, we must be in we first arrange the term in descending order. Means arrange the term descending order means here cube x cubic x cube x square x plus constant term. This is our descending order 3 2 1 0. They are descending order. This is not to rearrange. It is okay. But here 1 x square. It is ascending order. But we are must be trying to descending order. Rearrange to descending order. So we first write x square, then 2x, then plus 1. That is the right descending order. Then divide. And we got the remainder 9x plus x square. The degree of divisor is 2 and degree of remainder is 1. So the degree of remainder is less than degree of divisor. Okay, this is right. We also known as divide and equal to divisor into quotient plus remainder by division algorithm. So we can see if px and gx are any two polynomials with g of x not equal to 0, because g of x is the divisor. Divisor cannot be 0. We already know divisor cannot be 0, because if divisor be 0, then it is undivided. It is undivided. So dividend can be 0, but divisor cannot be 0. So by this theorem, we can say p of x into g of x into q of x plus r of x, where q of x is quotient. Here Here q of x is quotient and r of x is remainder, function of remainder. G of x is here, p of x is dividend, g of x is divisor, q of x is quotient, r of x is remainder. Where must be r of x equal to 0 or degree of r of x less than g of x, not less than equal to, must be less than g of x. Means divisor, degree of divisor is greater than degree of remainder, or degree of remainder is less than degree of divisor. This is known as division algorithm. It is known as division algorithm. By divide by this, before dividing we are rearrange this. It is not rearranging descending order. First x cube become first, then x square, then x, then 5. Rearrange, and it is non, it is also we rearrange this descending order, then divide. Here it is rearrange is descending order. Here also it is rearrange, then divide, and we get remainder as 3. 3 means degree of 0. Here degree of 2. Divisor of degree 2 and remainder of degree 3. Then the remainder of degree of remainder is less than degree of divisor. And that by division algorithm, divisor into quotient plus remainder, we putting this value, divisor, quotient and remainder, we calculating this and get the dividend. Okay, next the find the all zeros of the polynomial. If we know that 2 zeros is it, means 1 of 0 is root 2 and 1 of root 2 minus root. Then x minus root 2 is a factor of this, and x plus root 2 is the, by this 1 plus root 2 is the factor of this polynomial. Similarly, and x minus 2 and x plus 2 is also a factor of this polynomial. Therefore, x minus 2 is a factor of the given polynomial. Now we divide x minus 2 by this, and we get by this quotient as 2x square minus x, 3x plus 1. Okay, so therefore we written as this x square minus 2 into 2x square minus x plus 1. It is spelled above, but now we are splitting this and getting others two value. By splitting this, factorize and get 2x minus 1 x minus 1, and its 0 given by the x equal to half and 1. Therefore the roots are this. Okay, summarize. The polynomial of degree 1, 2, 3 are called respectively linear, quadratic and cubic polynomials. A quadratic polynomial with x real coefficient is of the form of ax square bx plus c, where a, b, c are real number with a not equal to 0. Must be a not equal to 0. If it is a quadratic polynomial, then a, the leading constant term, is not equal to 0. The zeros of a polynomial p of x precisely is a coordinate of the point where the graph y equal to p of x intersects x axis. Okay, means the graph which the position at the x axis, this is the value of the x of the polynomials of zeros. Okay, the quadratic polynomial can have at most 2 zeros. A quadratic polynomial can have at most 2 zeros, and cubic polynomials can have at most 3 zeros. Means at most, maximum of 3 zeros. A quadratic polynomial at most 2 zeros means a quadratic polynomial have maximum of 2 zeros. They can be none of zeros or 1 zeros or 2 zeros, not more than 2 zeros. The maximum number of zeros is 2, minimum number 0. 0 can be, 1 can be, 2 can be. Maximum is 2, minimum is 0. Similarly, cubic polynomial can have at most t, means at most t, maximum of zeros is 3. Number of zeros must be number of zeros 3. Therefore, we call polynomials, a cubic polynomials have 1 0, 2 0 or 3 0, but maximum 3, minimum 1 0. If alpha and beta are the zeros of the quadratic polynomial x plus ax square plus bx plus c, then alpha plus beta means sum of the zeros is minus b by a. Minus is, it is the first, then it is minus. It is the second, it is plus. First, then second. First is negative, second is positive, third is negative. It is the first, it is negative. Second is positive, means all odd is negative, all even is positive. Similarly, by cubic equation have alpha, beta and gamma are the zeros of the cubic polynomials. Ax cube plus bx square plus cx plus d equal to 0. Then it is first, alpha plus beta plus gamma, it is first. The odd, first means odd is negative, minus b by a. Then a to c, alpha beta plus beta gamma plus gamma alpha is second. It is second event means positive. Or and alpha plus beta plus gamma, it means it's thirds means odd, odds means negative, and negative minus d by a. Okay, a division algorithm states that the given polynomials p of x and non-zero polynomial g of x, that q of x and rx, such that p of x equal to g of x into q of x plus r of x, where r of x equal to 0 or degree of r of x less than degree of g of x. Okay.